So as the name suggests, mean value theorems are related to quantities that come in between two given quantities. And as it happens, we can use calculus to find out these in between values. So the first of the mean value theorems is Rolle's theorem. What does Rolle's theorem say? It says that if you have a function y is equal to fx and fx satisfies the following conditions, that it is continuous in the closed interval a to b, and it is differentiable in the open interval a to b, and the value of the function at the initial point and at the end point is same, that is fa is equal to fb, then there exists at least one point c somewhere between a and b and not including a and b, such that the value of the derivative of the function at that point becomes equal to 0. Let us go over it again. Rolle's theorem says that if you have a function fx such that it is continuous on a closed interval a to b and differentiable on an open interval a to b, and the value of the function at end point is same, then there exists some point between them such that the derivative at that point becomes equal to 0. How does it look graphically? Let's look at that. So here you have a sample function fx, and these are the endpoints. X is equal to a and x is equal to b. The function between a and b, as you can see, is continuous, and since it is a smooth curve with no breaks, it is differentiable throughout the function. Then at this point c, what happens to the function? It becomes horizontal at the point x is equal to c. So if you draw this pink color tangent at the point x is equal to c, the tangent is perfectly horizontal. That is, the derivative of the function f at the point c is equal to 0. Alright, so an important question that arises out of this is, why do we even require the function to be continuous in the given interval? So the answer to this lies in the fact that if it is not continuous and it still has equal values at the endpoints, it is possible for the function to not have the derivative equal to 0 at some point in between, like it is shown here. So this is the graph of a function from a to b. It has one point of discontinuity between a to b at this point, say D. Since it is not continuous, there is no point on this function where the tangent drawn is going to be perfectly horizontal. Can you see any point where if you draw the tangent to the curve, then the tangent will be perfectly horizontal? No, there exists no such point. And that is why Rolle's theorem does not get satisfied, and therefore it is not possible to find the point C where f prime C is equal to 0. And that is why it is important that the function be continuous and differentiable in the given interval for the Rolle's theorem to be applicable. Let us look at another example. So this again is a function which is continuous in the given interval. However, it is not differentiable at some point between a and b at this point. Suppose let's call it x is equal to e. At this point, since this is a sharp point in the graph of the function is continuous, however it is not differentiable, and therefore again it becomes impossible to draw a tangent which is perfectly horizontal at any point between a and b for this function. And therefore this graphical example highlights the importance of those two conditions for Rolle's theorem to be applicable. That is, the function should be continuous and differentiable in the given interval for Rolle's theorem to be applicable.